Bismillahirrahmanirrahim. Assalamu alaikum. Our today's topic is about hybridization. Now let's dive in a topic. Hybridization. Definition. Model that describes the changes in the atomic orbitals of an atom when it forms a covalent compound. The new set of orbitals are called hybrid orbitals. Definition: a mixing of the native orbitals on a given atom to form special atomic orbitals of bonding. For example, orbitals of carbon in ground state or in normal condition. It is 1s2, 2s2 and 2p2. Carbon contains 6 electrons. 2 electrons are present in 1s orbital, 2 electrons are present in 2s orbital, 1 electron in 2px orbital and 1 electron in 2py orbital. And hybridized orbital, atomic carbon hybridized orbital is 1s2, 2sp1, 2sp1, 2sp1 and 2sp1 electrons. Now the structure of carbon. It is the structure of carbon atom. It is 1s2, 2s2 and 2px1 and 2py1. It is the structure of carbon atom and the distribution of electrons in carbon atom in ground state or in normal state. The electronic configuration is 1s2, 2s2 and 2p2. First shell contains 2 electrons, 1s2, and second shell contains 4 electrons, that is 2s2 and 2p2. It is the atomic structure of carbon atom in ground state. Now sp3 hybridization. When 1s orbital and 3p orbitals belonging to the same shell of an atom mix together to form 4 new equivalent orbitals. The type of hybridization is called a tetrahedral hybridization or sp3 hybridization. The new orbitals formed are called sp3 hybrid orbitals. In case of carbon, 1s orbital, that is 2s, and 3p orbitals, that is 3px1, that is 2px1, 2py1 and 2pz1. They hybridize to form hybrid orbitals. It is 4 sp3 hybrid orbitals. 1s and 3p orbitals hybridize together to form 4 sp3 hybrid orbital. 1 sp3, 2 sp3, 3 sp3 and 4 sp3 hybrid orbitals. An atom mixed together to form 4 new equivalent orbitals. The type of hybridization is called tetrahedral hybridization or sp3 hybridization. The hybrid orbitals form tetrahedral geometry due to the hybridization of 1s and 3p orbitals. 1s, that is 2s1 of carbon, and 3p orbitals, that is 2px1, 2py1 and 2pz1 orbitals. They hybrid together to form 4 sp3 hybrid orbitals. 1, 2, 3, 4 and form tetrahedral geometry. These are directed towards the 4 corners of a regular tetrahedron and make an angle of 109 degree. 0.28 degree with one another. The angle between the sp3 hybrid orbitals is 109.28 degree. Each sp3 hybrid orbital has 25% s character and 75% p character. Example of sp3 hybridization is ethane, C2H6 and methane. This 25% s character. Each hybrid orbital contains 25% s character and 75% p character. This is the structure of methane. This is the hybrid orbitals of carbon. Sigma bond formed between hydrogen and carbon due to sp3 hybridization. It is the orbital structure of methane. Hybridization is a process in which two or more atomic orbitals of valency shell of an atom mix up to form the same number of identical orbitals of equal energy. This is the structure of carbon, 1s2, 2s2 and 2p2. In ground state, 2s2 and 2p2 orbitals. Now in hybridized orbital, it is sp3, 2s1, 2px1, 2py1 and 2pz1. They hybridize together to form sp3 hybrid orbitals. It is the s orbital, px present on x-axis, py orbital on y-axis and pz orbital z-axis. They hybridize to form 4 sp3 hybrid orbital. 1s and 3p orbitals hybridize together to form 4 sp3 hybrid orbitals. So here only lobes are present. They hybridize to form 4 sp3 hybrid orbital. The angle between these hybrid orbital is 109.28 or 109.5 degree. Atom with hybridized orbital. The hybrid orbital are shown slightly displaced away from the center for clarity. In the actual molecule, the minor lobes of the hybrid orbital are centered here. 4 sp3 hybrid orbitals in tetrahedral configuration. 1s and 3p orbitals. बिस्मिल्लाहिर्रहमानिर्रहीम वैलुल लिकुल्लि हुमज़तिल लुमज़ा। बड़ी ख़राबी है उस शख्स की जो पीठ पीछे दूसरों पर ऐब लगाने वाला और मुंह पर ताने देने का आदी हो। थैंक यू वेरी मच। अल्लाह हाफ़िज़।